Sir, can you please explain to us what are black holes?
There are many stars in the universe that are approaching their death. All stars burn hydrogen and then later other elements that come along, but ultimately they run out of fuel. Now, some stars will become black holes, and they will become black holes to the point that they will become invisible. Now, let me tell you a little bit about what the concept is. If I have a stone and I throw it upwards like this, well, it'll go up a little bit and then it'll come down. I throw it harder and it'll go further up and then come down. Now, suppose that I throw it so fast that it manages to escape from the Earth's gravity. But that's a speed of something like, I think, 25,000 miles per hour. Don't quite remember it, but some escape velocity. Now, that escape velocity, that is the speed with which you would have to throw it, would be much larger for, let's say, the sun. It would be much smaller for the moon. Now, imagine that you were to take light and you were to take a beam that goes upwards like this. So take a flashlight, hold it. Gravity acts on light. Earlier on, as we discussed, Einstein's equations tell you that light is affected by gravity. Now, if the gravity is so strong that light goes up and then has to come down, in other words, if it cannot escape the attraction of gravity, then we are in a black hole. So a black hole could be defined as a stellar object that is so extremely massive and so small that it will not allow even light to escape from it. Now, black holes were hypothesized. Of course, you can't know directly whether there's a black hole or not. What do you see out there? Nothing. They were predicted using Einstein's theory of relativity, the fact that matter bends space around it. It was a theoretical curiosity, but of course the question was, how do you possibly detect it? Well, here's how. Suppose that there is a black hole. Now, that black hole you cannot see directly, but let's say that you have another star, a visible star, one that's emitting a lot of light going around it. So something like this. This is a star that's orbiting around some center, some focus over here. Well, things don't just move in circles by themselves. There has to be some attractive force. That attractive force is provided by the black hole. So you cannot see this, you can see this. Such stars, which are called binary stars, and with one partner missing, that's one evidence of a black hole. Now, black holes, this is a prediction of Stephen Hawking. He, using quantum mechanics, using the theory of general relativity, made the following prediction. He said, let's say that this is a black hole. Now, contrary to what I told you just a little while ago, that nothing can escape from it, what Hawking predicted was that this black hole will be putting out a small amount of radiation. So there'll be light and there'll be particles that will be coming out of this black hole in all directions like this. And that goes by the name of Hawking radiation. Well, Hawking radiation is not something that we've observed as yet, but we certainly will at some point discover that. So that's another thing that a black hole does. So here is a binary star. There's a partner that you cannot see and a partner that you can see. Some such systems have been discovered. Astronomers are looking for them. They'll find lots more. But what's even more interesting is that at the center of every galaxy, like the Milky Way galaxy, which is ours, there are supermassive black holes. So these are huge black holes which have got masses of something like 1 billion solar masses. And what do they eat for dinner? Stars. They eat the stars, and out from that come particles, radiation, and so forth. What's one of the biggest discoveries in astronomy over the last decade or 2 decades has been that lots and lots of supermassive black holes have been discovered. So this is actually giving us very deep insight into the formation of galaxies, into the early history of the universe. One other thing before we leave black holes, and this is the prediction of Stephen Hawking. That prediction is that if I have a black hole, well, it's not that that is completely black. What Hawking predicted was that there's radiation that is coming out of it. And that radiation comes about purely because of quantum mechanics. Think of it this way. Suppose you have a very intense electric field between 2 plates. Now, if it becomes too intense, what it does is it rips the atoms of air in between them. And so you have a breakdown of the vacuum, so to speak. In deep space, there are no particles, but there is this intense gravitational field which just rips the vacuum apart, and out come the particles. That's what Hawking radiation is. It's a remarkable phenomenon. It has not been observed so far, but there are strong theoretical reasons to believe that it actually does exist.
So are you trying to say that no time-space exists inside the black hole?
Inside a black hole, time loses meaning. We can talk about time as seen by an outside observer. As you get closer and closer to a black hole, your clock starts going slower and slower and slower, and to an observer who is outside, your clock will have come to a stop by the time that you reach the edge of the black hole. Now, of course, long before you reach the edge of the black hole, the gravitational forces are so intense that any observer would be completely ripped apart. As to what happens inside a black hole, to my understanding, time loses meaning over there. Time and space do not have any kind of real existence over there. There's nothing that can be observed from outside as to what goes on inside a black hole.